Now, I'm really into this sort of stuff because I'm a really geeky mathematician, and I think this is beautiful and elegant. It's also handy to get an A or an A-star at GCSE because they're looking at proof. All the exam boards were looking at proving number theorems. So that's great for maths, yeah? But how can we use it in real life? Well, this is the real world now because I'm opening my coffee shop. Well, this is my new till. It's a beautiful new till, and it's really quick. I can serve a customer in 5 seconds through this till, OK? And I know, because my coffee's so beautifully good, that it only takes customers 30 seconds to drink because it's so lovely and milky. Oh, the frappes are lovely. 5 seconds to come in and 30 seconds to take a seat and drink the coffee. But that's the problem. I haven't got any seats, have I? Not one seat, because I don't know how many to order. But I want to make sure I've got enough. I don't want customers standing up with the coffee and nowhere to sit. But if I get 30 or 40 and I've got loads unused, I'll waste loads of money. I tell you what, I'm just going to pick 4. I'm going to guess. Well, we'll see. Let's open the coffee shop. Right, these two are going to be serving. So, I'm going to model the situation because we're not using real coffee. The stopwatch is going to be started by you, sir, Edward. After 5 seconds, Hannah will pass you a mug, and that's your cue to go into my coffee, sit down on a seat and drink your beautiful egg timer, which is set at 30 seconds. So when you've had your time in there, at 30 seconds, it will go a horrible bleep. You can go out the cafe. This is the back door here. I'll take your mug and start washing up over here. Everyone understand? Yeah. We're all ready to queue and we're all ready to go. So are you OK then, Edward, on the stopwatch? Yep. 3, 2, 1, go! First customer's in. 5 seconds. Excellent. Give it a good bing. In you go. Sit down anywhere. Don't mind. Excellent. 2 served up. It's going well. Drink up. Don't let it go cold. Excellent. Yeah, take a seat. Don't spill it. Come on. Oh, the floor's a bit slippy there. Be careful. That's right. Excellent. In we go. Take a seat. You're fine. Take a seat. Just sit down. Take a seat. Oh. We've got to stop. This is no good at all. This is no good at all. Oh, well, you can leave now, but it's too late. I've got 2 customers here standing up. I've got a big queue outside. Has it worked? It's just not happened at all. I know. Let's use algebra. What are we using? Algebra. Now then, I want S seats. And I want people to pay for P seconds. Paying time. It is a bit big, isn't it? Sorry. OK. This is number of seats. This is paying time. We've got another variable. What is it? Drinking time. Excellent. What should we call that? D for drinking. I like it. These are 3 variables. Now then, drinking time. So, we've got a situation. Seats required, paying time and drinking time. S depends on these 2 other variables. So, that's easy, isn't it? Put your hands up and give me the formula linking S, P and D. Mikhail.
Drinking time divided by paying time.
Drinking time divided by paying time. It's a lot of words to use. What's drinking time?
D.
Divided by?
P.
Right, that's very interesting. I think you could be right, because, like, if I'm the first customer, right, and I go in, and I'm sitting here on my first stool, I've just sat near the end, near the door, bit of a draft, OK, and I'm drinking for D seconds. In that time, there are people coming in at P intervals. So at the end of my D seconds, I have a certain number of P's who have come in since I've been in, all right? And that number is calculated by just simply dividing the value of D by the value of P. I think he's right. Let's just test this formula. Let's just test this, OK? By substituting values in, D equals, what's drinking time? 30 seconds, isn't it? What about the value of P? 5. 5, Arnold, isn't it? Yep, yep. 30 divided by 5 gives us what?
6.
6 seats. So, that's great. The algebra tells us that we need 6 seats. We've used the algebra to get the answer. So now, let's test it out. OK, 6 seats. I think this is going to work because we've used algebra. 3, 2, 1, go. Excellent. The first customer's in. Sit down. Enjoy your coffee. It's good, isn't it? Carry on. Go on, have a chat with him. Yeah? Go on, sit next to him, have a chat. Yeah? Good coffee? Nice. Excellent. Lovely. Going well. You're doing a good job there. Excellent. Is the till working? Yep. Yep. That's brilliant. Fantastic. Meg's the 5th customer. Are you happy, Meg?
Definitely.
Oh, it's good, isn't it? Good coffee. The seats are getting full. Brilliant. Yep, as one customer's left, the others come in. 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 OK, stop there. Take a seat, Krishnan. We've got all our 6 seats. They are all full. We've still got bleeping coffee behind me, but we've definitely tested it out and it's definitely working. We got to 6, all right? OK, customers. As the 7th customer came in, which is after actually 35 seconds, if you think about when we started the experiment, 5 seconds to pay in, first customer, 30 seconds to drink, first customer. After 35 seconds, he's leaving as the 7th one's arriving. OK? So it's working, isn't it? It's definitely working. And it will continue to work. And everybody's going to be happy, and my coffee shop's going to make loads of money. Problem solved. But there's a big queue, isn't there? Big queue. How are we going to reduce the queue? Let's have some ideas. Come on. Mohammed?
More seats.
Put in more seats. That's a good idea. Yeah. We could put loads in, couldn't we? What? So, like, put... Is that all right, Mohammed?
One more.
One more. Yeah, sorted. So if we run that experiment again... Hang on a minute. Can anyone see a problem with that? It's a good idea. I'd have thought of that.
That'd be empty seats.
They'll be empty. We'll always have 6 in, whatever happens. Think again. We've got a formula here to help us. S equals D over P. Meg?
Speed up the serving time.
Oh. S equals D over P. Speed up the serving time. So what we're going to do to the value of P?
Make it smaller.
Make it smaller. Excellent. Now, hang on a minute. If we make it smaller, if we make the value of P smaller, it's a variable. It can take any value. What's going to happen to the value of S?
Bigger.
It's going to get
Bigger.
bigger. Why?
Because something divided by something will make a certain number, and then if you make the dividing number smaller,
The denominator, yeah?
Yeah.
Smaller.
smaller, then it will become bigger, the answer.
The whole answer will become bigger. Excellent, OK? So if we reduce the denominator, it actually makes the number bigger because we're dividing by less. So it's bigger. And this is great because now I've got problem solved. My seats have bottoms on them, my coffee's getting drunk, and I'm very, very happy.